Hey, Angelo, thank you for coming in. I mean, you got such a marvelous background in AI machine learning. You're an entrepreneur. You've had a strong interest in these technical areas for your life and so on. So thank you for coming in and sharing your insights with my audience.
Thank you, Stephen. And I'm happy to be sharing my life journey. I started off in artificial intelligence via maths at a very early age. When I was a teenager, I realized that I have this ability to visualize maths. So when you give me an equation, I can actually see the shape of the equation. I thought that everyone knew how to do this. So much to my surprise, at around 16 or so, I figured out, okay, this is not something that everyone knows how to do. And so this led me more into computing. I took part in the Olympiads for Nerds, the International Olympiads for Informatics, and I had got a bronze medal back then. And I thought, okay, I'm good at this. So let me start selling software. So I started selling software on floppy disks back then, not even, before this predated actually websites, and started making enough money when by the time I was 18, I had made enough to, buy my own car, was much more financially ahead than my own peers. And I thought, okay, there is money in this. And this led me, to combine entrepreneurship together with my love for computer science.
I mean, that's interesting. You're saying floppy disks, but you don't look that old. I mean, floppy disks, that's a long time ago.
Thank you. Thank you. It must be the good weather and good Italian food.
So you indicated you had this ability to kind of visualize mathematics in your head and you were able to translate that into AI machine learning. So you had a really early interest and a talent for this, including then winning this sort of bronze medal, and because of the use of your capabilities. And that curiosity and ability, though, were there drivers in your family? Like, were there other inflection points in your life that encouraged you in this way? Maybe it was a teacher when you were very young, or as I mentioned, somebody outside of the family, in the family, other mentors. Were there other kind of transition points for you that made this wonderful career you have?
Yeah. I think that, I started off as a kid, I used to watch a lot of sci-fi, and Star Trek was my favorite. Obviously, Spock was my favorite character. So I know it sounds almost, like a cliche, but I really was inspired, in fact, to get into science because of that. And yeah, I started always, watching the NASA missions, Voyager back then. I was even writing as a school kid to NASA and getting, the photos of that were actually being sent by Voyager. They were actually sending them to me. Much to my surprise, I actually got NASA right back to me and send me stuff. And this actually was inspiring me. And I was lucky to have very good teachers also along the way who kind of always nurtured me, spotted the abilities, and helped me grow further. So I think, it was a confluence of, meeting people who recognized this and who encouraged me to continue. But I was always quite self-driven.
I see. Yeah, like you mentioned, Star Trek. Did you watch the original series, Dave, from the
Of
60s?
course. Yes, the original. Yeah, the original.
I
I'm 45.
And then the Next Generation, which was with Picard.
I watched absolutely all of them. I watched all the different variants of Star Trek by now. So I'm on this, and I read a lot of and watch also a lot of sci-fi. And I think that sci-fi has, in a way, managed to give us quite a lot of ideas of how things are shaping up. In fact, I programmed my first neural network in 1997. And back then, neural networks were seen as a toy, largely. Uh, some of the stuff that we are thinking, even when I was doing, say, my PhD, of what's possible and what is possible now, it looked like sci-fi back then, and now you realize, okay, this is stuff that we're actually discussing. Some of the discussions that we have recently on AI, on the capabilities of AI, the limitations of AI, would have sounded exactly like science fiction even like 10, 15 years ago. And this, I think, is a sign of how the field is progressing fast. And it's an exciting time to be in the field of AI.
Yeah, in fact, I'm going to go back to Star Trek a bit. There was this really interesting character called Data, and if you looked at the computational capabilities of Data, we actually exceed that now. If you
Exactly.
go back and research, he could do this many calculations, but we actually can exceed that in the technology we have. So it's interesting that you found that whole series inspiring, and you had reached out to NASA and they gave you stuff. And let's talk about your educational journey then. I mean, you had an early interest in mathematics and AI and so on, even before going to college or university. Then in university, did you study engineering, or what was that journey like?
Yes, so I started off by studying engineering and maths. So that's something good. And luckily, I grew up in Malta initially, and then I did my PhD and my education in the UK. Luckily, I always met lecturers who were strong in AI. One of the interesting facts is that Malta had an AI degree course since the early 90s, which was actually quite unusual back then. That was also a matter of luck. So I always had very good upbringing into the fundamentals, and I think this is very important. You've mentioned data. We don't have the positronic brain yet of data, and I think what was holding us back was actually the availability of hardware. And I think up to a good extent, it's also limiting us even in the present day. One of the things that I always knew and realized is that you always need to know the hardware that an algorithm is embodied in. Just, pure algorithms are interesting, but actually knowing how to implement them efficiently, and also being able to exploit the hardware that you're implementing them on, I think that is a key insight, in fact, and a key skill, which I think is being kind of left out more and more nowadays, which I think is coming back to haunt us because you get inefficiencies. And, we've been seeing manufacturers recently coming out with these chips that are optimized for certain AI tasks. And you see the difference in speed that you get. And I think it's very important, the fact that algorithms do not exist on their own. They are embodied into something.
Okay, so we're going to mine some of the things that you indicated. So I think it's interesting. You get this education in Malta, but you have AI and machine learning was recognized as being important early, even in the 90s in that school system. And so that's quite unusual.
It is indeed. It is. In fact, Malta had a lot of British influence, especially in the past, and I think this is also what led to yeah. But it's unusual actually.
Yeah, and then you go on and as you mentioned, you got your PhD in the UK. So, and again, it was specializing then in AI.
Yes, so basically my PhD was on, well, we would call them large language models nowadays. So it was on search engine technology, on basically seeing the effect of time. How does text change over time when you have news, when you have updates? And basically I was creating these timelines that just evolved as you added more and more text. Some of my early work even involved, like remember the time when we didn't have Unicode. So I was contributing a little bit to Unicode development, and also to the algorithms that were used in the Human Genome Project in order to align multiple sentences together. So basically back then, while I was doing this research on language models, I realized that the Human Genome Project, and remember back then, no one had an entire copy of a human genome that was sequenced. You kind of take the strand of DNA, you cut it up into small pieces, replicate it like thousands of times, and then you do kind of a majority read on the sequence that you get. And There wasn't a formula that actually worked out all the possible alignments of the string. So, one fine day, I had, just a bored weekend really, wrote down the equation, published it, and I think that is my sole contribution, in fact, to the field of bioinformatics. But it's used up till this day. In fact, there's the Dalli integer sequence that is named after me. And I think that also gave me an insight into how language models would evolve. So for my PhD, I had to download a copy of the entire internet, only the text portion, but this was in 2002. The internet was like a 21 terabytes file back then. And I had to spend like a £500,000, British pounds, to actually have enough hard disk to store that together with the indexes. And which nowadays is unmanageable. I mean, you can just go and buy an external hard disk, and which gives you probably 21 terabytes of storage. But back then, I literally had to build the hardware myself. So to do parallel processing, remember those like small boards, the ITX boards that you used for DVD players back then? I had to buy a lot of them, connect them together, and actually run Linux in parallel and do all this parallel processing. I think nowadays, obviously, things have got much easier to do, but I think that experience gives you a very good sense of the fundamentals and also of the limits of any technology.
Yeah, every time you say something, Angelo, there's so much richness in the detail. I have to go back and mine some of the detail. So earlier, maybe 10 minutes ago, you indicated that even in the 90s, you were working with neural nets. And the thing is though AI and machine learning has gone through these, winter periods, right? And neural networks were really discarded for many for many years, right? And then it rose in importance. And then maybe about 5 minutes ago, you talked about the importance of hardware and that there should be more of a kind of an emphasis on hardware. Now we're marrying hardware with the algorithms. In fact, even tuning the hardware to work much better with the algorithms, and the hardware is optimized to run these kinds of algorithms. So you can, I mean, Microsoft has now created their own chips. I mean, Google, of course, has, Apple has their own chips, and so on. So the whole semiconductor field is just exploding to work with these AI and machine learning models. And here you're part of all that journey. And then you indicate that you worked in bioinformatics and the Human Genome Project, and you were able to help contribute in a significant way to the point where it's even named. There's parts of it named after what you were able to contribute. That's pretty pretty remarkable. So on the hard, so let's mine some of this hardware side. I did this talk in Munich, and I had a little bit of Philip Wong embedded in there, and of course Philip is working on carbon nanotube chips, and they're already being produced. He's working on resistive RAM and 3D architectures, and with that, you can maybe get up to 1,000 times improvement in performance and 1,000 times a decrease in the amount of power required. So that's a whole new, in fact, they even have these chips being produced that just trying to bring the cost down. And then that tech will then really supplant any of the existing tech on these more general purpose chips. But then you have these specialized chips as well that you're mentioning, right? Which are optimized for matrix multiplication and things like that, and optimized for AI. And so it, and you indicated more should be taught in that area. So where do you think that all of the chip area is going? Yeah, I mean, there's even a lot of progress in together with resistive RAM, but these kind of Faro type RAM, which is better, more efficient. And so where do you think all of that semiconductor industry is going? Do you think it's going to be where we can get more of these large language models on the edge because of the improvements in chip technology, and you don't have to go to the cloud? Maybe that's what Apple is working on. There's a lot of guessing on what Apple's large foundation model tech will be looking like, but some are theorizing that maybe they're spending a lot of time because it's trying to shrink it so you can get it onto your iPhone, so you don't have to go to the to the cloud. So
Exactly.
because you have this abiding interest in hardware, where do you think all of that hardware, where is it going? Can you predict, let's say in 2 to 3 years time, where do you think the hardware is going to be?
So for me, I always see the hardware and software together. Um, uh, One of the areas that I'm working on and that I've been focusing on is called neuro-symbolic AI, which marries neural nets together with the symbolic logic. So it's like taking advantage of the flexibility of neural networks, but also the power of being able to use logic processes, inference, deduction, induction, abduction, basically going backwards from the cause to the diagnosis, from the symptoms to the cause, and so on and so forth. So being able to process cause and effect. And I think all of these new architectures, including LLMs to an extent, but I think when it comes to neuro-symbolic even more, they need to have hardware that is optimized for that. When you think about it, a GPU, which is again, I started using GPUs early on for the transportation industry. We're doing monitoring of vehicle traffic. We're doing like license plate recognition, this kind of stuff. And when CUDA came out and GPUs started coming out, you could see immediately, okay, this is like really good stuff, good hardware to run AI on. However, it is not really optimized for AI and machine learning. So by having processors that are more attuned to tensor processing, by having the memory together with the processing, like you see neuromorphic chips, for example, I think there will also be a resurgence in FPGA type of chips. And also seeing how graph computing, which is still in infancy, having hardware graph processors, I think that is the way that the industry is going to go. For example, if you take a neurosymbolic model, it's basically taking a neural network, which is also a graph, but computing it directly onto that. And that is fantastically powerful to do. If it gives, much faster results. And I think that, yes, we will see AI on the edge. At some point, I think it will become too expensive to run AI on a data center, even in terms of speed. If you want to use it in an application, say in your car, you have to run it on board in order, to overcome latency concerns. And so I do think that we'll have to find ways to run powerful AI models on the edge. And we have proof that it can be done. Biological systems do it. So, there's no reason why we cannot do that. I think another area of interest is also it's called like spin neural networks, in which you have also like temporal neural networks, in which you have time as part of that. I think that is something that is also interesting and reduces the power usage. So there are a lot of things where the software and hardware can work together, mostly in memory access and computing, combining the two together. Recently, for example, there has been a really interesting development when it comes to 1-bit quantization of large language models. There has been this recent paper where they use ternary logic in order to compress it even further, literally putting most of the weights to -1, 0, or 1. But then you realize, okay, but my question to the authors was, but you're using a binary computer to implement this. What about the fourth bit? Kind of, how are you implementing 3-level logic with 2? How are you doing that efficiently? And you start thinking about, okay, why don't you have such hardware basically available? So you never know, maybe the future architecture of AI could be based with this exotic stuff that it seems exotic now, but maybe will be commonplace in 5, 10 years' time. So I do think that the semiconductor industry is going to be, working hand in hand with the developments of the software.
It's really interesting, all of this work that's being done, and all of these companies are looking at it. I mean, the big tech companies are looking at producing their own chips, right? And looking at optimization in any way possible, so there's a better alignment where things are going. I think it's fascinating that you have this neurosymbolic part of logic combined with neural net. So are you then a supporter of Jan LeCun and what he's doing? Because he kind of deviates from, what OpenAI is doing, and he's saying, that is not the answer. It's got to be something more, some kind of hybrid. And it seems to be that's what you're suggesting as well. It's some kind of hybrid model, right, going forward to get AGI, and you won't get AGI from LLMs. Though there was a paper that came out maybe about a month ago about using random graph theory to analyze how LLMs are working, and then seeing that there's this kind of very unique, almost skill capability that's appearing and in a novel ways, which suggests that maybe there's some kind of underlying worldview model, some understanding that goes beyond this sort of probabilistic sort of prediction of what's coming next. So I'd be interested to hear your views on that. The Jan LeCun work looks like you're more a supporter of that kind of hybrid. It sounds like you don't think LLMs are really the key to AGI. It's got to be some kind of hybrid model. But then there's some evidence to suggest there's something else going on in these large language models as you scale them, where they're doing novel things that are not in the training data. So I'd be interested to hear all of this, all of your viewpoints on all of this.
Yes, and it's very interesting topics actually that you mentioned. I was lucky to have a brief conversation with Jan LeCun actually on this, and also I'm very aware of his ideas about this architecture that he calls JEPA, that's basically based on compression, effectively on encoding and compression, which is at the heart of machine learning, being able to compress something and being able to learn about it in that compressed state, kind of basically attention, focusing on what is most important is at the key of learning at the end, being able to see what is important and generalizing it. I don't think that LLMs in their present form are going to be the best solution actually that is going to lead us to an AGI-like world or even world models. I do think that in LLMs there is a little bit of encoding in there of a world model because it is being trained on text. So language itself inherently has a world model in it. But I don't think that there is a world model in there. So I disagree with views that, for example, were expressed by even quite influential computer scientists about this. There, I tend to agree more with what Jan LeCun says, with what Gary Marcus has been saying this for a long time, that the future architecture is going to be based on neuro-symbolic AI. I firmly believe this for the reasons that you mentioned. One of them is the world models. How do you model the world unless you actually have some kind of way of expressing key facts about it? When you think about it, what is a symbol? A symbol is a way for us to be able to compress a lot of information about an object in the world and being able to reference it, to name it. That is something that LLMs, while I think they are really good at being able to predict, plausible and implausible, but likely future sequences of a particular occurrence, okay, given an object, generate more similar to it. I think there's a use for that. It's, in order to kind of do brainstorming to try to see, okay, what is the search space to be able to cut down that. So I do think that LLMs will be here to stay. So generative AI is going to be here to stay. But the problem is that you cannot trace the output back to the input. I think this is a problem, and this is what neuro-symbolic AI can solve. And the problem of hallucination. I mean, again, the starter computer, we were used to having AI that actually replies in a reliable fashion. All of a sudden, we've had AI that can lie to you, that can make stuff up. It's not what people used to think of AI as doing. And I think that the problem of the algorithmic hallucination can be solved by having plausibility checks, plausibility in terms of a world model. So being able to understand cause and effect, being able to do basic logic processing. This is something that an LLM architecture in its present form just cannot do to the same level that a neuro-symbolic version of transformers, for example, would be able to do. And this is, in fact, something that I've been working on in order to say, okay, how do you attribute from the source? The source is basically the output. How do you go from the output back to the sources? How do you do this plausibility checks? How do you actually detect when you're hallucinating and when you're not, when it's plausible or not? And this leads to the link of trust, because if you have an AI model that cannot explain to you its decision-making process, you cannot trust it. So this, I think, is very important for us to be able to collaborate with AI on a day-to-day basis in a large scale, especially having it on the edge. You need to be able to understand it, that it can explain to you what's happening in case of an emergency, in case of some kind of outlier, some strange case. You need to be able to correct it directly and thus collaborate with it. And I think this is super important step that I think current LLMs have not yet managed to overcome.
You know, Judeo Pearl got a Turing Award a number of years ago, and I sat down with him. I interviewed him and had some long conversations with him. Just really interesting. And if you look back, maybe even 25 years, he's come up with this causal model and like a framework. Have you looked at his work? It's really quite interesting, right? So,
Yes. In fact, Judah Pearl is one of the people who has inspired me a lot on how to model cause and effect. And he's right. His, like rungs of causality, his tree system, in which basically you can be able to can you measure counterfactuals? Can you imagine a world that is different in just one or more ways? This is something that, in order for AI to be able to integrate with human society, it's a key capability that AI needs to learn. And I think this is very important. In fact, his ideas maybe are a little bit more advanced, a little bit difficult to actually implement sometimes. But I think that, yeah, Pearl's framework is in fact something that we will actually see in the future incorporated in most AIs. Maybe in its present form, maybe slightly modified, but I think these ideas have to be there. And when you think about it, when you look at how people learn cause and effect. For example, you've seen maybe recent videos, especially video generation of like seeing a glass fall and like liquids, pours out of it, but you see it, you expect it to have actually broken into pieces, but you just see liquid flowing out and the glass remains intact. And as a person, that this doesn't make any sense. It is physically impossible to happen. And I think there is a deep link between people's sense of survival, nature, the physical constraints that the world puts on us, that actually forces us to learn a world model, whether we like it or not. You cannot survive without it. And I think causality presents a framework to be able to couch that in a formal way. How do you model imagination, basically? I see Judea Pearl's work in the field as a way of being able to formalize that and being able to, actually understand what is the probability of a distribution of kind of an imaginary world, of a counterfactual world.
I mean, I think it's worth it. Do you know Judea? Have you talked to him in person? I think you should talk to him in person.
Exchange messages every now and then on Twitter.
Okay, so you've looked at his that mathematical model that he's created, right? I mean, it's interesting, and he insists that, or at least in the time I've spent with him, he insists that if you do this, you will get. If you're going to have any path to AGI, you have to use this model that he's created. So I think it's really.
He's correct. I think he's correct.
Yeah, but like you said, then how can you implement, right? But he's laid it out, right? So. And I know he's sponsoring research in the area as well, at least the last time I talked to him. But you had Jeffrey Hinton come out last year, and he came out pretty forcefully that he thinks there's something else there, and maybe even it's better than humans. It's different. It's just maybe even better at learning. And then when this random graph theory paper came out, and I could be wrong on this, so I really encourage the audience to take a look. But I think he was saying that people should look at this paper because, again, it's showing that there's something else going on, and that something else could lead to, just enormous capability, right? In a way that we may underestimate. I mean, that's me putting my words on him, but that's kind of like the way I interpret him looking at it. And then one of the senior researchers at Microsoft who looked at the OpenAI work and was able to then sort of be part of that lead team that resulted in Microsoft um, working with the OpenAI people. I thought I saw a comment that he looked at that paper as well and saying, you know what, it's people should look at this, that there's more there, and maybe there's more capability, right, than we think, right? So
Yeah.
especially as we
Um,
scale these models, right? So
Yeah, I mean, Hinton came out with a lot of comments lately about this,
yeah,
and I think, obviously he's one of the grandfathers of AI. I mean, I think neural networks have gained popularity. He has a direct, contribution, a major contribution to the field. However, I do not actually think that some of his statements recently have been totally correct, actually.
right.
I think that when it comes to the world model, I do not think that LLMs, in fact, have a world model because it's not there. It's just not there in the implementation. We do not have any form of world model explicitly modeled in there, and you do have, this process of feed forward process in which you get this vector embedding and this path through vector embeddings that is getting ever more refined, but LLMs in their present form are still doing very fancy next word prediction. And while there is, I think what I think is happening is that because I know also Julia Pearl was doing some experiments on this. I think in language we have causality and world models that are so inherently ingrained in it that you literally cannot speak to another person without having these elements inside language. So I think what is happening is that the language model is picking up these structures that we as people have encoded in language itself, and that is what is giving the illusion of a world model. And it's interesting, in fact, because I think this also points the way into how representation of data and representation of scenarios should be made. And I think it is very important because, yeah, language is imperfect, but maybe it is more powerful than we thought. Computer scientists tend to sometimes overlook the power of language as a representation medium. And, just being able to formally specify things may not be the optimal way. Maybe we've hit onto something that is more optimal, that actually encodes this in language itself. And I'm sure, like linguists have a lot of theories about this, much more deeper about, the semantics and the semiotics of language. But I think there is something in there that is actually making language models pick this up. And it's inevitable when you have a model that is trained on such huge masses of text that it's going to pick up these patterns that maybe not even, the best linguist in the world has ever picked up on it. So, I think there are effects that are being masked. So the actual causes, unfortunately, the abduction process is a bit faulty in some of the statements that are being made.
Yeah, I mean that's fascinating. Again, in the talk I gave a few weeks ago in Munich, I mentioned Mind AI. So Mind AI is really focusing on the sort of symbolic side, and they created their own way of doing things, and it's fully transparent. You can trace the way it comes to a decision, and they can marry with LLMs and so on, but they believe that you have to have this component, right? Otherwise, you can't trust it. So,
Yeah, yeah.
um, it's interesting what you're saying. Taking this from kind of an oblique angle, kind of another way of thinking. You have the scientist Yamanaka, and he came up with this four factors, these genes that you can inject, and it can convert a adult cell into a stem cell. And a variation of that work is once you have a pluripotent stem cell, you can coax it to be a brain, like a mini brain, organoid, and try to put some scaffolding on it so you can get a little bit more complexity. But what if you look at that work dating back to, let's say, 2018, 2017, they're able to get these brain organoids, kind of like mini brains, growing from stem cells and coaxing them. They start generating electrical activity. And that electrical activity actually models very closely a fetus, the early stages of a fetus. And then they found that at a certain stage, that progression of the electrical activity just doesn't continue to progress. So again, 5 years ago, there was speculation, and the reason that there was this plateauing was because you needed embodiment. In other words, you had this kind of detached mini brain, and it's growing in complexity and capability, even showing electrical activity that mirrors a fetus of something going on, but then it plateaus. It doesn't progress because you need sensory mechanism feeding to help that brain organoid continue to develop and to progress. And of course, there's all sorts of ethical considerations of, how far should you progress this? And it's become, that whole field has become much better through better ways of scaffolding this so you can get more complexity. But then there's the idea that if you're creating neuro-symbolic, some kind of AI and machine learning, that ultimately you have to embody it into a robot. You have to embody it into something, and that's going to allow it to progress even to a further kind of AGI state. And so you see that big announcement, right? Investment in Figure, where OpenAI is invested in it, and Microsoft and Bezos and so on, because they're working on the embodiment side. So what do you feeling on that? Do you think the embodiment of this is required to get to something that's very much more closer to who we are?
I think so. I think that embodiment is important, in fact. First of all, giving an object, an entity, a sense of self is very important. I think being able to refer to, self, I think is important, and being to able to manipulate the environment and do interventions. Judea would call them interventions, but being able to actively do them and then see, okay, what is my expectation? And what is the real outcome, and what is the difference between them? It's a very simple, concept. It's the whole concept of feedback in all the engineering control theory. But this is something that AI cannot do actively for itself. It cannot just say, okay, let me change this and see what happens. It has to rely on data that we feed it or that it gathers off the internet. In a way, it's like, imagine trying to learn science, trying to learn about the world, but being blind and unable to actually do anything yourself. You have to passively learn from everything. You can do it, to an extent, but I think you learn much more when you can actually do stuff, when you can actually intervene, when you can create the data points for yourself. So one of the interesting things about neurosymbolic AI models is that they know what parts of the model are strong and what parts of the model are weak. So if you had to embody a neurosymbolic AI, it will know, okay, I am weak on this part of the data, of the input-output space. Let me do more of this. Let me actively try to gather more data about this. And I think this would be incredibly important, because when you think about it, it is how we have learned, how human society has actually progressed and learned most of its knowledge, tinkering around a little bit, saying, okay, this may work, or by pure accident, discovering something and then following it up and doing variations of it. And I think that once AI can actually do this, I think it's going to spur such a growth in the learning of AI, because it will be able to learn for itself, not just totally unsupervised, but also be able to actively set agenda itself. which obviously leads us to a lot of questions about control, about, how to actually being able to guardrail that, and there are lots of these questions around it. How do you give AI the ability to do that in a responsible way? How do you keep it safe? And, those are, I think, the important questions that need to be answered and solved. But I think we've come some way to actually solve those.
So, I did this Vinod Khosla in February fireside chat for the ACM, and he made a number of predictions. And one of the predictions he's made, and again, I don't want to represent what he's saying, so I encourage people to take a look at the on-demand recording of the fireside. But my impression was he was indicating that robots are going to be these just commonplace, that they're going to be everywhere, and it's going to be, many of them, and they're going to be integrated in. So do you feel then that within the near time frame, I'm not talking 50 years out or 100 years out. In fact, I don't think you can predict that far out anymore because we're so much
Yeah.
change, double exponential kind of innovation is occurring. Do you think in 10 years that, you may have a humanoid robot in your home, or you may see
Definitely.
them walking the streets or so on?
Definitely. I'm not sure that much about the humanoid aspect. I have my own ideas on this. But definitely we're going to have robots all over the house. I mean, we already have simple robots around the house. I mean, I have my little vacuum robot, and, that cleans the floor and does all the stuff. And uh, I think that this kind of limited applications are already showing their usefulness. Even if you have driver assist in your car, even if we don't have full self driving in cars, but it still helps if the car is able to brake automatically if it detects a potential collision, if it keeps you in lane. This kind of little assistance, I think, is very important, and I think this is how it's going to be introduced within our daily lives. I'm not sure about the concept of humanoid robots. I was once lucky to be on stage with Sophia, the bot, which is a pretty realistic robot. But you could see, like the uncanny valley started kicking in. And I think that while I almost, you laugh it off, there is an actual issue in this. In that I think if you try too hard to make a robot look human, if it then doesn't behave exactly human, you're going to hate it. You're going to have actually this emotional response to it. I actually think that I would rather have robots that follow their form and function. And if it's a robot that will help me in tasks around the house, give it 8 arms. Why do you want to give it 2 arms? So it can do things faster. I think that we will have a lot of robots, but I predict that they will not be humanoid, actually.
So it's really fascinating because you see this massive investments by different companies and even different individuals, and really humanoid embodied robots, right?
Yeah.
It's like and bringing autonomy to these robots as well, so that they can generalize, right? So you don't have to train them on specific tasks. They can generalize and work with the environment in a generalized way. So it's kind of interesting. We'll see what happens. I mean, definitely you're going to get specialized ones because they already exist, right? And that are
Exactly.
not humanoid, and that
Yeah.
are in
Yeah.
different shapes and form. Even drones, I would say, are kind of like robotic in a way, right?
Oh,
So,
yeah. And
um,
the ability to be able to work cooperatively, I think we'll see more and more robots of different types that cooperate together in order to achieve a task. And this is something, in fact, that is missing from LLM architectures, the goal plan task architecture. And I think this is very important, that future AI needs to have a very strong grasp of this, of being able to set an objective, being able to set a goal, planning it, splitting it into tasks, and being able to allocate it to different resources. If they are robots, okay, how do you cooperate? How do two robots work together in order to achieve a task? I mean, I think we're going to see more of this, to see 2, 3, or more robots actually working together as a team in order to achieve something. And when you think about it, that's how us people actually became, dominating the entire world. If we had stayed everyone, on their own in their little cave, we would have never actually managed to grow as the human species. So I do think that all the successful, actually, when you look at nature, all the successful species have had this cooperation together, and which is the basis of society. So I think that robots will also need to be able to work as a team. And I think this is very important.
Yeah, I mean, that's the embodiment of the human body, right? We have all of these specialized cells, and these specialized cells are cooperating with each other to produce what we are, right? So,
Yeah,
and working in unison. Though it's interesting if you look at AutoGen and some of the work in LLMs, they're and the fact that they've added memory, they're testing memory, and so there's persistence, and planning is in there, and then this auto generation of you have a target goal and it iterates to reach that target goal. But that there's
yeah.
work even in LLMs to do that, and so it'll be interesting to see what the world is going to look like in a few years, right? As all of these different areas progress. Um, I would say though LLMs are probably getting the most attention right now, and a lot of funding going into this area. Let's mine a little bit of your entrepreneurial experience. So, what caused you to form your own company, and then subsequent companies after that? You've had multiple exits.
Yes.
Can you describe that journey? And also aware of the time. This is totally unscripted. We were having a meeting and we converted into an interview. So I want to make sure that you don't have a hard stop in like 5 minutes or something like
Yeah.
that.
Yeah. No, that's fine. Yeah, so basically I was always attracted to do this, especially since, yeah, when I started off in software, I started making money almost immediately. And I liked it, obviously. So, I didn't inherit money. I made everything, by myself. And I thought, okay, let's do more of this. And I think that the experience gained by interacting with people, by seeing their problems and how to solve them, and coming up with solutions that generalize, products, basically, I liked that journey of productizing the solutions. And I applied AI to many different industries, including transportation, to retail analytics, to e-commerce, when it came to entertainment, recommendation systems. So I, over time, you start kind of seeing also the commonalities between different industries. And at the end, you realize that for most commercially important software, useful software, there are just a handful of functions actually that you do in combination with each other, and they produce commercially useful results. And I think this is what has led me always. I mean, I think serial entrepreneurs are a particular breed of people that you thrive on stress, that you do not really like things to be too easy, too cushy, and that you just always want to improve things and invent new stuff, and also being able to exploit what you've then created and making commercial success at it. So yeah, there has been always this drive to actually do this, and it literally gives you a hit, like to be able to successfully launch a product, to close a deal. It's something that actually pleases you, and I think, yeah, it's kind of chasing that hit. I did try, in fact, retirement for a few months, um, around 5 years ago or so. Yeah, I lasted 3 months, and then it was boring. So I was surprised that I lasted 3 months, actually. I think that what my entrepreneurial journey has given me is the ability to be able to be free to choose and pursue now what I think is the most important stuff. So, for example, being able to look at the limits of deep learning 5 years ago, identify what are going to be the limits and how to overcome this without being, boxed in by a lot of constraints, especially financial constraints. And I think that on the other hand, I also enjoyed a lot also mentoring other entrepreneurs who wanted to start startups and mentoring them, also putting in small angel investments. I think this is also has been very satisfying to see the positive impact that you have on other people and to also see the success stories and also making some money out of it, but it's kind of a very low priority in fact in this in by placing good angel investments in a timely way.
Well, I mean, it's fascinating, right? Because you got this computing science background, engineering background, you've got a PhD, and often people with PhDs end up in the academic world, but you were able to translate this into a series of successful startups and companies where you're embodying your expertise. And like you said, you thought of retiring for a few months, but you couldn't do it. You had to give back and not, but you have the ability to more deeper mine your interest of the neuro-symbolic application and seeing the limits you think of neural networks, and that's got to go in this sort of other direction, or at least in a kind of some symbiotic direction, right, with what's out there.
Yeah.
And but you have the means to pursue that kind of work in a deeper way than, let's say, if you didn't have these companies and exits and so on. So just a remarkable journey. I mean, we could probably spend the half a day talking about different ideas, but I'm sort of conscious of your time as well. Do you have any sort of final thoughts you want to give to the audience? And this could be something really esoteric, like Roger Penrose's work, where he thinks that quantum effects are happening here, and it can't be just some kind of discrete, you know, neuro-symbolic, electrical, chemical activity. It's something else going on, or it could be something very practical. You know, what kind of thoughts do you want to leave the audience? And that's my last question.
I think that that AI is here to stay and it's gonna be more and more increasingly part of our daily lives. I think that also that with the creation of AI that is transparent and trustworthy, we can not need to, overhype all this stuff about doom and gloom that AI is gonna kill us all. AI is not gonna kill us all. I think that it is people who need to use AI responsibly. Like the saying goes that guns don't kill people, but people kill other people with guns. This is very true, in fact. And I think if we use AI responsibly, it's going to unlock a lot of human society's civilization potential that we have never actually managed to do before. I think it's an exciting time to create inventions basically based on this. And I do think that neuro-symbolic AI is going to be, well, part of the foundation of that future AI that is going to be pervasive, that is going to run on the cloud and also on the edge. And we're going to see hardware that is specialized to run that software optimally. And it's going to be exciting to see AI being able to do, manipulation of things, embody, learn for itself. And who knows, maybe we will learn also from the way AI is learning and vice versa. I think it is basically creating something that can be a mirror of our own development from which we can learn and we can teach. So I think it's going to be exciting, and it's something that we never had as people. And I think it's going to be exciting to see how it unfolds in the next, 5, 10 years. And this is not going to be something that's going to take a long time to unfold, but we're literally already starting that process.
And I was talking to an evolutionary biologist, and he suggested maybe we're just a part of this continuum, and that really AI or some hybrid is the next iteration of who we are, right? So we in our present form are going to disappear, just like Neanderthal and Denisovans aren't out there, are contemporaries of ours, though we carry their DNA, right? We have elements of the DNA of this other human kind of cousin. And do you think that? Do you think that our species is going to change, and that we are just part of this continuum of evolution?
I think, look, I think that as time goes by, we will learn actually how to manipulate ourselves. Um, uh, And we've already started manipulating ourselves. I mean, the mRNA vaccines, for example, are a key step, a baby step in doing that, for example. And I do think that humans and AI are going to be closer and closer with each other. So you will see people who will have embedded chips, for example, or, I think it's going to become commonplace, in fact. I do want people to stay around. So, I'm not one of these people who wants to like totally replace people with AI, because I think that would be totally sad. I think AI's function is to actually help us do more to enhance, our presence, and we can actually cooperate together. So I do think that it is inevitable that we will find ways to modify our genes, with the help of AI, possibly, with the help of nanotechnology, to increase longevity. I don't think that longevity is going to go away anytime soon, but I think we'll be able to have good quality of life extended by 50 years, extended by 70 years. I think this is within the realm of possibility, and I don't think it's that far off. So this is an exciting time, also a good application of AI in order to, find ways of doing this in a better way.
Yeah, it'd be hard to predict though, because AI and machine learning is unlocking so many different capabilities, but you're also new kind of semiconductors, quantum computing, analog computing, these hybrid computing models are going to be able to solve NP-complete problems, NP-hard problems, nature problems that we can't even conceive of right now. But Angelo, thank you for coming in and doing this unscripted interview. I really enjoyed my time with you. So thank you for sharing so many of your insights, and yeah, brilliant career, and your brilliance and your contributions are continuing. So thank you for everything.
Thank you, Stephen.
Thank you for listening to the Brand Called You videocast and podcast, a platform that brings you knowledge, experience, and wisdom of hundreds of successful individuals from around the world. Do visit our website www.tbcy.in to watch and listen to the stories of many more individuals. You can also follow us on YouTube, Facebook, Instagram, and Twitter. Just search for the Brand Called You.